This is Algebra 1, Lesson 4E, Multiplication and Division of Fractions. So when you multiply fractions, you can multiply straight across. So that's 4 times 7. I'm going to use a dot for my multiplication. And that'd be 28 over 15. And then you look to see, do they have any common factors? And if they do, you could simplify it. These do not. I can, so you can't simplify it. I can change it to a mixed number. A whole in this problem would be 15/15, right? And we have way more than 15 up here. Let's see how many extra we have. We have 13 extra. So it's like we have 15/15 and 13/15. That's what this 28/15 is equal to. So I have enough to make one whole plus the 13/15. So that's equal to 1 and 13/15. For B, you're going to be dividing fractions. Now, to divide fractions, it's easier, well, really the only way to do it is to multiply by the reciprocal. So I'm going to keep the first number. I'm going to change the divide to multiply, and I'm going to flip the last number. I always tell my students that dividing is the same as multiplying by the reciprocal or the flip. A lot of students are taught Kentucky, keep change flip, Kentucky chicken flip. They sometimes call it. You keep this number, you change the divide to multiply, and you flip the fraction. Okay, it's the same as multiplying by the reciprocal. All right, now we have a multiplication problem, and we can multiply straight across. Here, we have 4 times 8, which is 32, and 3 times 15, which is 45. And they do not have any common factors, so that's your answer. All right, number 3, or letter C. This is similar to the first one, and then once we change the second one, but there's going to be something a little bit different. If you work this out and multiplying it straight across, you're going to have a good bit of simplifying that you need to do. So what we're going to do is we're going to use a strategy called canceling, and you've done this before. This is a reminder. You can cancel if they are diagonal from each other this way, or if they are diagonal this way, or if they're top to bottom, or top to bottom here. You just can't cancel straight across. And why is that? Well, you know with fractions, like if you have 2/4, that it's okay to divide the top and the bottom by 2, right? We get 2/4 is the same as 1/2. We know that both of those are equal. We could draw a picture showing that 2/4 is exactly the same as 1/2. And that's because we're able to do the same thing to the top and the bottom, which has the net of not changing it at all. It's like if you were multiplying this fraction by 2 over 2, you get 2/4. Again, 1/2 is equal to 2/4. You can think of that as, I just multiplied by 2 over 2. And what's 2 over 2? It's 1. And when you multiply by 1, you're not changing the value, right, of the number. We can multiply anything by 1 and it stays the same value. So let's look at canceling here. These two have something in common. How many 3's are in here? Well, there's only 1. How many 3's are in here? There's 10. 10 times 3 is 30. So it is okay to go ahead and divide both of those by 3. That's what canceling is. It's really division. Now I'm going to multiply what's left straight across. 7 times the 10 is 70. Over 1 times the 9 is 9. Now when we get that, we can say, hey, I've got way more than 9/9. I've got it way more than 1. How many 9's are in there? How many wholes can I make? Well, I'm just going to go ahead and do a division. Let's think about that. Let's see. 8 nines is 72. 7 nines is 63. And I would have 7 left. So I have enough to make 7 wholes, and I'm going to have 7 ninths left over. It's another way that you can do your mixed numbers if that's easier for you to think about. So the answer would be 7 and 7 ninths. D. When you've got a string of multiplications, you can still cross cancel. I notice here that those will cross cancel. So let's do that. How many 5s in here? 1. How many 5s in here? 1. How many 3s in there? 1. How many 3s in here? 2. And then we can keep looking around and seeing, let's see, I have 1s, 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 here's a 2, but there's nothing here that will cancel, so that's not going to help me. So we can just go ahead and multiply what's left straight across. So I have a 1 times a 1 times a 21 over a 1 times a 2 times a 23. So that's going to be 46. 21, 46. Now, I don't have enough to make a whole, because a whole here would be 46 over 46. So, and there's no common factors, so that's my answer, 21, 46. E. When you're multiplying mixed numbers, you need to change them to improper fractions first. So let's do that first. Here, just like in that last one, I have 2 wholes. So that's kind of like I have 2 over 2 plus another 2 over 2 plus a half, right? So that would be 2, 4, 5 halves. Okay, I know this is going to be 5 halves. There's a shorter way to think about it, though. I know I'm going to have 2 of these plus an extra here. So what you can do is you can say 2 times 2 is 4 plus the 1 is 5. And that's all over your denominator. So 2 times 2 is 4 plus 1 is 5 over 2. And then I'm going to multiply that by, let's do our shortcut here. Can you try it? 5 times 3, which is 15, plus the 1, which is 16, over 3. Now I've got those both written as improper fractions, and now I'm able to multiply. I do see something I can cancel. How many 2's in here? 1. How many 2's in here? 8. Multiply straight across, and you get 40 over 3. I've got way more than I need for one whole. There's a bunch of holes in there. Let's do the division and see how many. 3 into 4 would be 1. Bring down that. 3 will go into 10 3 times. And I'm going to have 1 left. So that's 13 and 1/3. And that's your final answer for E. For F, again, I'm going to change it to mixed numbers. So 12 times 3, this 12 times this 3 is 36. Oh, I forgot to add. 12 times 3 is 36, plus this is 37. Thirds. This is still a division, so I'm not going to try to flip anything just yet. Let's do 2 times 6 is 12. And then we're going to add this. That'd make it 13. So 37 thirds and 6. 13 sixths. Then I'm going to keep, change, flip, or multiply by the reciprocal. Now I can see what can I cancel, and you can see here that these will cancel. How many 3's in here? 1. How many 3's in here? 2. And you multiply straight across. 37 times 2 would be 74 over 13. And then how many 13's do I have in 74? I'm going to say, let's see. If we said this was about 10, there would be 7 of them in there, right? And I think that's probably a little too high. So let's try 6. 13 times 6. 6 times 3 is 18. 6 plus 1 is 7. That's a little too much. So it must be 5. I'm going to keep my scratch work in case I need it. 5 times 3 is 15. 5, that'd be 6. That gives me a 65, right? So I'm not using all of them. That means I can fit 5 of them in there. And what I'm doing here is I'm finding out how many 13s in 74. And I have figured out that it's going to be 5. And that's going to leave me 9 pieces left. So that's equal to 5 and 9/13. All right, G. G looks a little bit scary, maybe to some people. It does look different. Like, why are they stacked like that? Well, one thing we talked about, I believe in another video, we talked about division and how you can write it in different ways. I think the next video we're going to review that, talk about that a little bit more. This bar means divide. So I could rewrite this if I wanted to and say 3 1/3 divided by 2 1/5. And then you have a problem just like we did just a minute ago. So it's really not that scary. It's just written differently. Now it's really important that you write the top number first because we read top to bottom, left to right. So write the first one, the top one first, the numerator, and then your divide, and then the bottom one. Okay, and that'll help you get it correct. So now let's just change them to improper fractions. 3 times the 3 is 9, plus 1 is 10 thirds, divided by 2 times 5 is 10, plus the 1 is 11 fifths. Now it's a division. Let's change it to a multiplication. 10 thirds times 5 11ths. Can I cancel anything? I can't. So let's multiply straight across. We've got 50 30/3. Now, that's enough to get a hole in there. And 2 holes would be 66, right? 33 thirds plus 33 thirds would be 66 thirds. And I don't have enough for that. So 1 hole. And then how many are going to be left? So here's what I'm doing in my head. I'm actually doing this division. And I'm saying, I know that would give me something here left. It's going to give me 17. So 17 30/3 left.